The Adirondacks' dark secret, a century of industrial pollution, and the slow march toward recovery. Boldly nestled amidst the pristine beauty of New York's Adirondack Mountains lies a tale of environmental resilience and human intervention. For centuries, these majestic peaks have lured visitors with their lush forests and crisp mountain air. In the late 1800s, they even served as a sanctuary for tuberculosis patients seeking solace in the cool, fresh air. Today, the region remains a cherished retreat for families and hikers alike. However, beneath this idyllic facade, a hidden danger has been lurking since the dawn of industrialization. As industrialization took hold, tiny metal particulates from factories, power plants, and vehicles across the Midwest and Canada embarked on a journey thousands of miles long, carried by the wind and deposited by rain. Among these microscopic pollutants were lead and cadmium, notorious for their toxic effects on human health and wildlife. For decades, factories released these pollutants without restraint, leading to the formation of acid rain that decimated forests across the eastern U.S. and caused the accumulation of airborne metals in even the most remote Adirondack lakes. But here's where it gets controversial. How effective has the recovery been? And did the Clean Air Act, enacted to curb pollution, truly work its magic? Unearthing the past, a journey through time, in a recent study. Paleolimnologists embarked on a quest to uncover the environmental history of the Adirondacks. Armed with inflatable boats, GPS, and long, heavy metal tubes, they ventured into the backcountry between 2021 and 2024. Their mission: to extract sediment cores from 4 ponds, Rat, Chalice, Black, and Little Hope, and analyze the layers of mud, leaves, and pollen that have accumulated over time. These cores, meticulously sliced millimeter by millimeter, revealed the concentrations of metals like lead, zinc, and arsenic, painting a vivid picture of the lake's transformation over the centuries. A century of contamination, the rise and fall of industrial pollution. The sediment cores told a story of 2 distinct eras: the pristine nature of the lakes before European settlement, and the dramatic shift as factories sprouted across the country. Starting in the early 1900s, the burning of coal, smelting, and the use of leaded gasoline unleashed a torrent of pollutants into the air. Manganese, arsenic, iron, zinc, lead, cadmium, nickel, chromium, copper, and cobalt began to accumulate in the lakes, their concentrations skyrocketing. Acid rain, formed from sulfur and nitrogen oxides, acted as a catalyst, freeing more metals from the bedrock and forest soils. The result was a cascade of metal pollution that swept through the region, contaminating waterways and ecosystems. And this is the part most people miss: the impact of extensive logging and massive fires, which stripped away vegetation and topsoil, creating a pathway for metals to wash downhill. When acidification met these disturbed landscapes, metal levels didn't just rise, they soared. In some cases, lead levels in the sediment reached 328 parts per million, a staggering 109 times higher than pre-industrial levels. These particles, so small they could infiltrate lungs and food webs, posed a significant threat to human health and the environment. A turning point: the Clean Air Act and the path to recovery. Public outcry over the devastating effects of acid rain, which stripped needles from trees and poisoned fish, led to the Clean Air Act's inception in 1963. This landmark legislation, along with subsequent amendments, began to reduce sulfur dioxide emissions and other toxic pollutants. Industries installed scrubbers to capture pollutants before they could be released into the air, while catalytic converters in vehicles reduced exhaust emissions, and lead was phased out of gasoline. The air grew cleaner, the rain less acidic, and the lakes began to heal through natural biogeochemical processes. By 1996, atmospheric lead levels at Whiteface Mountain had declined by 90%, and national levels were down 94%. However, the lake's recovery was slower, with lead concentrations decreasing by only about half. In the past 5 years, since around 2020, metal concentrations within the lakes have finally fallen to less than 10% of their peak pollution levels. This study marks the first documented case of a full recovery in Northeast U.S. lakes, reflecting the atmospheric recovery. It's a testament to the power of environmental policy and timely intervention. Looking to the future, challenges and opportunities. While the Adirondacks have made significant strides in recovery, the threat of legacy pollution remains. Contaminants linger in the soils, ready to be remobilized by future disturbances from land development or logging. New concerns, such as the rise of microplastics and the pressures of climate change on lake ecosystems, also loom on the horizon. Recovery is not a finish line, but an ongoing process. And the Clean Air Act and water monitoring remain crucial for maintaining the region's air and water quality. The lessons learned from the Adirondacks extend far beyond their borders. Studies from past decades have documented declining metal deposition in lakes, and research has confirmed continued reductions in metal pollutants in both soils and rivers. The layers of lake mud not only bear witness to the damage inflicted, but also serve as a testament to nature's resilience and the potential for recovery with good legislation and timely action. The story of the Adirondacks is a beacon of hope, reminding us that with collective effort, we can restore the balance and safeguard our natural treasures for generations to come.